eosinophil looks like, and neutrophil looks like, and what their general functions are. Okay, so these three are your granulocytes. You see the sandy granules, right? And this one here is a neutrophil, okay, multilobular. It's kind of a little pinkish, sometimes it's a little bluish, the granules, and then the nucleus is going to be more tinted in the direction of whatever the granules are tinted in. So this one pinkish, there's a little bit of a pinkish tint here. Versus for eosinophil, you're going to have a reddish granules, but the nucleus will be blue or purple. And then if it's a bluish granules and it's all over, then you're more likely thinking basophil. This here is lymphocytes, and this is monocytes. So remember, the lymphocyte, the nucleus is pretty large compared to the rest. And then for the monocytes, the nucleus is not quite as, it doesn't take quite as much of the cell space. And then the cell itself is pretty large. Okay, so what is this? Neutrophil. This? Neutrophil. What about this one? Neutrophil. What about this one? Monocytes. Okay. What's this?
Red blood cell.
Red blood cell.
Platelets.
White
blood cell.
White blood cell. Okay, this slide here, I just want to remind you, so red blood cells carry a whole lot of hemoglobin. And each of those hemoglobins have 4 binding sites for oxygen. Okay. And in terms of anemia, what is the definition of anemia?
Like
Low blood cell.
not enough blood, low blood cells.
Low red blood cells, low hemoglobin, right? And then what are their symptoms?
Weakness.
Fatigue and pallor, right? They're kind of pale, pallor and fatigue, right? And since they have low red blood cells or low hemoglobin, they're not able to transport enough oxygen, right? So they're tired a lot. Okay, so now we're going to focus in on your APO system, which is one of those ones that we want to take some time with. So if you are blood type A, then you can be AA or AO. But what does that mean? What sort of antigen do you have?
A.
A. And what sort of antibodies do you have?
B.
B. So anti-B antibodies. A antigen, right? If you're blood type B, you're BO or BB. So you have what sort of antigen?
B.
B. And what antibody? Anti-A antibody, right? And then if you're AB, then what do you have on your cells? A and B. So what sort of antibodies do you have?
None.
None. And then if you're blood type O, what antibodies do you have? Anti-A and anti-B, right? So in the cell, in the plate that you guys did on your exam, then you put in blood, the blood cells, right? And then you put in, and as well as your A, B, and RH, right? So the law that was labeled A, you put in anti-A antibody. So if you put in anti-A antibody, what are you looking for? What's the antibody looking for? A antigen. That's right. So if you put in anti-A and it was looking for A antigen, what would happen if it found A antigen?
Agglutination.
Exactly. You would have a reaction occur, and that would be agglutination, right? So if agglutination occurred, that means A antigen was in that well, right? So that's positive for A. The presence of A antigen was there. So if for the B well, you put in anti-B antibody, and if agglutination occurred, what's present? B antigen. Okay, so if both wells agglutinated, A and B, what is the blood type?
AB.
AB. If only well A agglutinated, what's the blood type?
A.
A. A. And then if only B agglutinated, what's the blood type?
B.
D. Okay, so if D agglutinated, what's the blood type? It would be positive, right? So if you put it for the RH wells, you put an anti-D or anti-RH, whatever you want to call it. If it's agglutinated, that means the D antigen was present, right? So if it was present, then you add positive to whatever the blood type is. If it wasn't present, then there was no D antigen, and so you add negative behind whatever blood type it is. Does that make sense? So all three wells agglutinate. What is the blood type? AB positive. If none of the three wells agglutinate, what is it called?
O negative.
O negative. Okay. So if A and RH agglutinated, what is it called? A positive. Okay. So if you have all three wells agglutinate, you told me that that's AB positive. Who can they donate to? AB, right? AB. Who can they receive from? They can receive from anybody, right? Because if they are AB positive, they don't have any antibodies to anything. So they won't react to any of the blood types, so they can receive from anybody. Okay? So if that's just the A well and the D well, RH well, agglutinate, what is it called again?
A positive.
So who can they donate to?
A
A
positive.
and AB, right? And who can they receive from? A and O, right? Because O has no antigen, okay? So we need to think about, just think about what's on the cell itself. And so the recipient, you have to think about what antibodies do they have. And the donor, you have to think about what antigens do they have. So when we talk about donating blood, we're really talking about donating red blood cells. So what sort of antigen do they have on their red blood cells? And what will the recipient have in terms of antibodies that will react to it? Okay?
You're using just like A and AB for the donating, but like for the positive and negative, positive can only donate to positive, right?
Yes, but it's less likely of an issue. For our case, we're just talking about, for RH, I want to talk about RH in terms of pregnancy. Okay, in terms of baby, but in terms of AB donating.
You're not worried about it?
We're just going to focus in on the A and the B.
Okay.
Okay? Yeah. Yeah, we could talk about like RH in terms of pregnancy. But in terms of blood, we're focusing on ABO, right? So this is what agglutination looks like. It clumps up, right? So if there's no clumping, then that means no reaction occurred. Okay. So in terms of pregnancy, what really becomes significant is only if the mom is negative. If the mom is positive for RH, it doesn't matter, right? Because that means she doesn't have any antibodies. She won't develop any antibodies against the B, right? But if she's negative, she can develop antibodies after the first pregnancy or when her blood is exposed to the baby's blood. Okay, so now we're going to talk about the clotting. So this picture shows, the red blood cell, that vessel is punctured, red blood cells and blood is kind of leaving, and as it leaves, you get this clot forming right at the wall here. And again, you want to kind of remember the difference between intrinsic and extrinsic pathways and what cofactors are associated with it, right? So intrinsic How do you remember that? It's inside. It's related to the blood vessel, right? Inside the blood vessel. So TEN, right? TENT